Welcome to the wonderful world of miscellaneous problems. Basically, that just means that all of the info that we've done for the whole chapter so far is all in one question. Yay! First thing we're doing is proving that BD is 55 sine 35 over sine 16. So let's work out where BD is and see which triangle that's going to be useful for. We want it to be the sine rule, so we know which sides we're going to need. We know some angles that we're going to need. Probably not that side, actually. Let's use, because we're going to find 16 degrees in there. Let's find our angles first, and then we'll work out which other side we need. We've got that side of the triangle, so we're probably going to have to use the obtuse triangle. And 90 minus 61 gives us our top angle up there, and our top angle is 39 inside there in BDA. And our top angle for BCA, which is that one with the 35 in the corner, is going to be the 90, so it's 180 internal plus we're taking that 90 away from that right angle. And it'll be 90 minus our 35, giving us a total of 55. So that little bit on that left hand side is our 55 minus our 39, giving us a lovely 16. So now we've got two angles in the same triangle. We've got one of the sides of that triangle, and we do need the second side of that triangle. So BD is, of course, that lovely line there. I'm going to grab this third angle just in case. You never know when you're going to need some info. We might not need it for this question. We'll probably need it later. Now, we know we're going to use the angles 16 and 35 because they were the ones in the question that we had to try and prove that was correct. So we're then going to find our 16, which is across from our 55, and our 35, which is across from that side that we don't know, which is the BD, fortunately. Alright, chuck it into the lovely sine rule, and we have BD over sine 35 equals 55 over sine 16. Moving around to get BD on its own, and guess what? BD equals 55 sine 35 over sine 16. Question A done. B, distance between Chris and the bird. So Chris and the bird, let's just clear up some space here because we've got a lot of drawing all over that triangle. Okay, angles might be useful. Let's chuck the bits back on that we might need. We want this side here. So we're going to need that 16 up the top probably. We're going to need that 55 down the bottom. But we're also going to need that third side that we found, that 129, because it's the one that is opposite the side that we now want. And again, we can use the sine rule to do that. So our 129 in the side we want, our 16 up the top, and our 55 that we were given from the actual question. Well, the 55 we were given from the question, the 16 we found out earlier. And CB over sine 129 equals 55 over sine 16. So CB is 55 times sine 29 over sine 16. I'm going to grab a calculator to work out what that one is in a sec. And here we go. Now, you've noticed I've done a couple of times previously, and I'll probably do it again at some point in my life. Be wary when you put numbers into your calculator, make sure they're the right ones. It seems silly, but it happens. This one we're going to 3 significant figures, so 1, 5, and 5 are our 3 sig figs, and stopping there. How high the bird is from the ground is the BA section. So we've got a bunch of different ways we can do that at this point. I am going to suggest one in a second. We've got a whole bunch of angles and we've got a side, but also guess what? There's a right angle triangle, and we know how to use right angle triangles. That is actually the opposite of angle 35. We know what the hypotenuse is, we just worked it out. So why not just use our normal sine from our original ratios from our right angle triangles? Which would be our sine 35 is our opposite over our hypotenuse being 155 to 3 significant figures. Okay, so we've got our h at the top, our o on the side, and just writing our equation out so we can work out how to get o on its own. Sine 35, as I said earlier, is our opposite over our hypotenuse of 155. And moving that to get o on its own, we'll have o is 155 times sine 35. Chuck him into a calculator, going to 3 significant figures again. And let's see where we ended up. So we've got 88.9. So 1, 2, and 3 significant figures. And next question. Alrighty, 13. A boat travels 90 kilometers from X to Y on a bearing of 65. So 065. Got our compass down because, bearings. 65 goes up in this lovely bit here. It then turns on a bearing of 140 to point Y. From point Y to point Z, which means we're going to have a whole lot going on. Z is on a horizontal line starting from point X, which means it's going to be on that Y. Means it went straight down. And okay, so the 50 in there is our 90 degrees from north to east, plus the 50 gives us our 140, which is where my 50s just come from. That pink line is going to need to go all the way down to our east. So we've got our lovely triangle there, our X, Y, Z triangle, and we are first going to work out the size of X, Y, Z. So that angle up the top. Just draw that on so we know which angle we're talking about. Might grab a different color. Okay, X, Y, Z. And there he is up that top section there. That's what we're looking for. So we've got some information already. We can get that right-hand side because we know that north to south is 180 degrees. We know that the northeast was 90 and that little bit there was 50. So the leftover in there should be our 90 minus our 50. Our left side is, of course, our alternate angles to get 65. If you're forgetting what your alternate angles are, it's between parallel lines on the either side of the transversal. Transversals being the lines that go straight through them. The words don't matter. You don't need to be able to tell me where you got that info from. Just, know that you know how to get there. Adding those two together, we end up with 105 as our answer for our angle XYZ. Angle YXZ is, of course, our 90 degrees minus our YXZ is 90 degrees minus 65 because we had that 90 degree angle between north and east. I think it's the other side, 25 degrees in that little bounce there. How far is the boat from X now that it's sitting at Z? We've got some angles, we've got a side. Guess what we can do? Yeah, that's right, we can use the sine rule. Fun times. So what we're going to do is find the third angle in the triangle. So we've got 180 minus our 105 minus our 25. And that third angle is going to be 50 degrees. And then chuck your airplanes, your band-aids, your sausages, whatever you're going to call them. Chuck your sine rule information on there. Do our lovely circles. Our 50 degrees is across our 90. Our 105 is across from the side that we want. So x on sine 105 is 90 on sine 50. Move it around to get x on its own, and x is 90 times sine 105 over sine 50. Chuck them into a calculator, go 2 decimal places because that's what the question asked for. And we should be sweet for question 13. Calculators are calculating. We calculate with calculators while we calculate. Calculators are calculating. So 113.48. Have a good day.